Dzień dobry. That's the only Polish I know. No, I know another Polish. If you make a real French baguette, then you have prepared part of the dough the day before, and that's also called Polish. So that's the other Polish I know. Dzień dobry and the thing. So really sorry about that. I only talk English or German or Danish. If you want to ask me in Danish, questions Danish, feel free to do so. Yeah, good morning. I'm really impressed. I thought the first session after the party, nobody would show up. So I see the Polish people really know how to party and how to show up for the first session. I really appreciate this. My very first time to Poland, and I'm really impressed about the conference. I'm really impressed how nice the weather is. I've seen part of the city yesterday, but I only walked through the parks, so I don't know how the buildings look like, but I know how the trees look like here. So, welcome to my session from SQL to R. So, R is a new thing, and when I try to learn new things, I always start at things I already know. So I thought it could be interesting setting up a talk about how you can transfer your knowledge you already have with SQL to learn R. So you know how to query things, you know how to group things, how to filter things in SQL. That's what I expected to do. And I will show you how you can do the same stuff with the help of R. So you get a quick introduction into the language. So the most important slide is this one, the sponsors. I know you paid some fees for attending here this conference, but without the sponsors I don't think we would be here. We wouldn't have a party, we wouldn't have a lunch or coffee breaks. So I really think that's the most important slide, and I hope you already visited all the booths of the sponsors. If you did not so until now, please do so, because if there are no sponsors, no visitors to the booths, then there will be no sponsors, and without no sponsors there will be no SQLDay 2018, I guess. Who is me? My name is Markus Ehrenmüller Jensen. As you can hear from my accent, I'm not from Poland, I'm from Austria, so I have a German accent in my English. I speak English-German, and as I said, this Jensen part is an original Danish one. My wife is from Denmark, and that's how I learned Danish, because I wanted to know what her family is talking about me. So that was the way how I learned this weird language. I'm not a good language guy, I guess, but that was motivated me to learn Danish. So my contacts here, I work with the Microsoft Data Platform since version 2005. Already got a little bit my hands on the 2017 version, which is out in CDP2 version now. It should be in RTM in the upcoming weeks or months, I guess. We will see. I'm quite active in the community, so there's an Austrian, so like the PLSSUG, there's also an Austrian version of it. It's called Pass Austria. I'm the chapter leader there. We're doing SQL database in Austria on Fridays. So if you want to visit Vienna in January, on January 18th, which is a Friday, there will be a SQL Saturday, and it would be really nice to see some of you, or all of you, visiting Vienna and having fun with the day of conference. There's also a book outside, the 2 courses on plural side, and I'm really happy that it was awarded as an MVP with the beginning of this year, so it was a really good start for me, being awarded with this nice award. So what's the agenda? I have a few slides about what R is, why you should be motivated to learn R, why I think that R is important. Then we go very fast into demo mode, and we'll stay in demo mode until the end of the session, so I hope you're good with demos, and I hope the demo gods are working for me today. And we will also see, because R as a language is nice, but it is heavily integrated since Microsoft acquired the Revolution R company, so they're now really heavily integrating the R language into the data platform, and that's what we will take a look on. So we will see how R is integrated to the database engine, how R is integrated to Power BI, and there's also this machine learning, Azure machine learning. I did a talk introduction into this yesterday, and I see some familiar faces, so I'm really happy to see people again showing up. So what is R? R is a programming language, as you might guess, and it's strong and dynamically typed. We will see this in demo, what that means. It's a functional language, it's interpreted, so you can't compile R scripts. You always have to take the script and it's executed as a script and not as a binary. R is open source, which is on the one hand really, really good, because the community is very active. I think the R community is as active as the SQL Server community, so there's really things happening there, and the language and the packages are really evolving, and it's growing, so that's a good part. So when some guy finds a new nice machine learning algorithm, there's a good chance that it puts a package together and publishes it on the ground, which is the sort of GitHub or Codeflex for R scripts, R packages. But on the other hand, it's always also confusing because we already have more than 10,000 packages out there and on that ground, and there are also other packages available. So it's really hard to get started with 10,000 packages. In each package there's, I don't know, several algorithms implemented, so it's really hard to get started with that. And there's also no standard. So neither the packages are named by standards. There are packages called E1307. You don't have a clue when you just read the name of the package, what the package is about. Or some fabulous packages are called car, or really funny name, Sue is one of the fabulous packages. And just with the name you can't guess what the package is about. So that's an advantage and a disadvantage. And there are three reasons why you should learn R, or what R is about. One is the statistical packages. So there are lots of packages. If you're into the statistics, matrix calculation, distributive statistics, then there are packages out there where you can easily do this task. Matrix calculation, I can remember that I did this in school, forget everything about it, don't know a clue anymore about it, but it's rather easy. You just take two matrices and you just calculate with those matrices without knowing what the rules are. R just can cope with that. Then there is machine learning, which is really interesting because there are lots of packages out there where you can do regression algorithms, clustering, neural networks. So that's the second reason. And the third reason is that there's a bunch of packages out there where you can visualize the data in very nice ways, in ways I would love to have in the Microsoft Data Platform, and now we have, because R is, for example, integrated in Power BI, and we can use R packages to generate those visualizations and just use this in Power BI, as we will see at the very end of the demo of this session. So, what are the things in common? There are things in common. R and SQL is used by data people. So I guess all of us, we're working with the data platform, and R is a nice addition to, as an additional language to work with data. We can extract data, we can load it into memory and variables, we can transform data, we can analyze it, we can even visualize it in R, not so much in SQL. We can, both are interpreted languages, so we can't compile things. We have to share the script and not the binary. And it's available on Microsoft's data platform because Microsoft acquired the company Revolution R, so R is open source. But there was a company who came up with an enterprise version and server version of R, and that was not open source. That's something you had to pay for, and now Microsoft acquired the company and is integrating the stuff into the rest of the data platform. The R language is very popular. Some say it's #1 analytic language in 2016. You can use it for analysis and data visualization. It's really growing. Yeah. As I said, we hit 10,000 packages at the end of 2016, I guess, and it's still growing. There should be more than 2 million users out there who are using R actively in their daily life, and it's a language for mathematicians and statisticians and data scientists. So most of the data scientists use either R or Python. Today we will talk about R. Open source community, really active, as I said. Tons of packages out there, which is really good, but also confusing when you start with that. So now we're going into demo, and before we go into demo, I just found, yesterday I found this nice thing here out there, the TOBE index. They are trying to get data from Google, from different forums where are discussions, and they think that R is the language number 14 now, so they were language number 16, ranked number 16 1 year ago, and with this month they are ranked 14, so the community is growing and people are growing, and I guess one of the reasons is that it's now integrated into Microsoft Data Platform, so the Microsoft guys are now using R language. Let's start with an R script. What I have here is the Visual Studio. So most of the data scientists which are not used to Microsoft things are using the R Studio. And Visual Studio just try to replicate the screens for within as a Visual Studio add-in. So as it is a Microsoft sort of a Microsoft conference, I decided not to use RStudio today, but the Visual Studio with the R integration. So what we've got here is, I've got a script, already opened the script here, which is here. And then we've got the console down there, so I could type things out there and execute them, or I just can mark things in the script and execute it, then it would copy it down to the console, and the output will be shown in the console. Then we have some explorers here. The most important is the variable explorer. Can you read this? Should I zoom in a lot better? So there's the variable explorer, where we can, where every variable we are creating through the scripts is shown. So you can see what's the data type, what's the content in it, as you will see throughout the demo. And down there we either have now the solution explorer, but usually you see the plots here, or the help, which is also very important. So there are not many standards for the R packages, but one of the standards is every package has to be documented, and there's a help function for it available, to at least explain the syntax for this. So the most important part for a language is the comment, because I don't know who of you are developers and who of you are really like to write documentation. Not many do. So the best place for documentation is the source code, because when you see things going there, you can explain it there. If you see that the comment is outdated because something changed in the code, then it's very easy to change the comment, but nobody really dares to change any documentation. So I think that's the most important part of a language. And we have comments. So with the hash sign, we assign that the rest of the line is a comment and will not be interpreted. Unfortunately, there are no multi-line comments available, so if you have comments which are longer than one line, which is a good idea to be make long comments, really explain what's happening, then you have to use multiple of those hash signs. And I can execute this, nothing happens because this is just ignored, so you see down the comment here, but no output. For calculations, as this is a language from or for mathematicians, of course we can calculate. Wow, yeah. So 1 plus 2 is 3. It's much more easy than with SQL. With SQL we would have to write select 1 plus 2. In R we just can write it without select. We can multiply, we can use the potential of 2. You see 16 bits would be end up in number 65,536. We can also work with variables, as I said that variables will show up here, so we can do assignments. And this is open source, it's open-minded, so there's not just one way to do assignments, but several ways of doing assignments, which is really funny. So one way is to use the equal sign. A is the variable, equals the code or the text SQL to R. And if I execute this, we can see that now a variable is showing up here. So the variable name is A, and the value is equal to R. We can use the very same by left assignment. So this does not mean lower minus, but this is a left assignment. So I take the value like on the right and move it to the variable which is on the left. That's a left assignment. The same thing will happen. That's it. Or we could do a right assignment. So we can take the text and assign it to the variable which is showing on the right. And of course it's a functional language, so we also have a function to do assignments, which is really nice. So this function accepts the variable name in quotes. We can use single quotes or double quotes. R doesn't care, there's no distinguish between these two, which is really nice, because I always get confused by different languages. Some have single quotes, some have double quotes. In this case I'm just free, use single quotes or double quotes, whatever you want. And we can also assign the same value to the variable A. So when I want to display the content of the variable, I can either show or view the variable window there, or just type in the variable name, execute this, and it will show me that it's equal to R, the content. The assignment function is really nice, because the parameter doesn't have to be a constant, but can be a variable. And when I do this, so assign A and another content, then we can see that we have another variable showing up there. So in this case, the assign function did evaluate the content of the variable A, which was equal to R, and now created a variable with the name equal to R, and assigned it the content, another content to it. So that can be confusing, so be really document this very well if you're using it this way, because maybe people would expect that the variable A gets the content equal to R, but it's double evaluated. The funny thing. No? So we have the variable A and the variable equal to R, which is another content. Then I said that the language is dynamically typed. That means that we don't have to declare the type of the variable, but we assign values to a variable, and through this it's typed. So if I assign the value 1 to A, which up to now was a string, as you can see here, a character, I can just use the same variable, assign 1 to it, and now it's changing to 1, as you can see here, without the quotes, so now it's an integer numeric, not a string anymore. We can also use a shortcut if you want to assign something and then evaluate the variable, the output. You can also use the parentheses. So in this case, the value of 1 is assigned to the variable A, and A, the content of A is displayed at once, so I don't have to use 2 lines of code to show the thing. We can also use create vectors. So C is a very important function, shortcut for combine. So in this case, all the parameter values are combined to one vector. So in this case, A is not anymore a numeric, but a numeric vector. And you can see here, it's showing there the numeric vector of the 2, so 1 until 2 is the length, and the content is also 1 and 2. It's also strong typed. So if I take a variable like assigning 1 to it again, take another variable assigning a string to it, and then try to calculate A plus B, so 1 plus a string, this will not work, so we get an error message here, so it's strong typed. Even if it's dynamically typed, it's strong typed, so I can't use the wrong data type for doing my things. And the combination would be here, like of course, when I have the right content, then I can calculate A and B and add this to another, which is to multiply 3. R is, in my case, unfortunately, case sensitive. I don't like case sensitivity because I'm very lazy in typing or using the lowercase and uppercase. I just change this randomly. So I never use or try really to avoid case sensitive conditions in SQL Server because it drives me crazy. But R is case sensitive. So when we assign SQL to R to a variable with the uppercase R, then it would be a different variable, as you can see here. So there's the variable A in lowercase with a numeric value, and then there's the variable A in uppercase with a different value. So there's different things. The language is very function-based, so there are lots of functions out there. I will not execute all of them. For example, to quit the studio or quit the console, that's a function called to Q, like quit, or there's help out there, so I can help. And that the help will be displayed. I can also use a shortcut by just marking things out there and pressing F1. So the help is showing up there in the right corner and tells me what the help, in this case the help function, because I've marked the text help. So it's showing me how the help function is working. You can also see the license, which is open source. We can see the contributors. If you are using R code to build something and publish it, you are sort of forced to tell people that you use R for this, and this is explained with the function citation, the option source sync, and so on. And just to make it short, for the descriptive statistics, I said there are 3 things which you would do with R, or why would you use R. So one is the descriptive statistics, the other one was the machine learning, and the third one was the visualization. So to make it short, for the descriptive statistics, we can calculate, for example, the mean. I put a vector to the mean, create a vector on the slide of the combine function. So I create the mean function as the result of the C function. The C function is returning a vector with values 1, 2, 3, and 5. And when we do this, then we get the mean of 2.75. We can calculate the median, which would be 2.5, which is just in the middle. So half the population is bigger and half the population is lower than 2.5. Or we could calculate the standard deviation very easily. So there, if you're into descriptive statistics, there are lots of things out there, alone in the base package without installing several packages. And if you need more sophisticated stuff, then there is a lot of packages out there. So let's move on, leaving the basics, talking a little bit about the data types. So we have also, as it is strongly typed, we have data types there. So we already seen that there's a numeric data type with the mode function. It displays the type of the variable, which is numeric. If I signed it, in this case with double quote, I also could use single quote, then it will be a character. As you can see here, there's no change, double quotes, single quotes, both of those are characters. We have, like the Boolean or the bit in SQL, we have a logical data type, and we have even a complex data type. Maybe you can remember from school, I already forgot everything about that, so don't ask me about the complex data type, but it's out there and you can use it if you really want or need. Yeah. Special values, there's also, there are 3 types of null values. So in SQL we know the null value, some use it like it would be empty, which is a different thing. Hopefully you know that null is not empty, that null is not 0. In R we have 3 types of null values. So all those types will end up as a null value in the relational database, but not so in R. So dividing something by 0 will end up in infinity, ENF. I also can use this as a constant, and I can check if something is infinite. For example, 4 is not infinite, 3 divided by 0 is infinite, or inf is of course infinite. There's also negative infinity. I was really impressed about that, didn't care. Up to now I didn't have the problem in my life to define negative or positive infinity. Now I learned about this. So, of course, we can use the same functions here. 1 is lower than infinity, 1 is not lower than minus infinity, of course. So we can also use just expressions and let this expression evaluate, which will end up in a logical data type which says true or false. The second thing which would be null in the SQL database would be not a number. So dividing 0 by 0 ends up being not a number. We also can check, is something not a number, is dot NaN. By the way, the dot is not a reserved thing, so we can come up with variables containing dots, which is a little bit confusing if you come from the SQL word, well, because the dot is always used to distinguish between the table or the database, the table, the schema, and the table name. Not so in R, so we can use this as part of the function name or variable name, and we can check if something is not a number again. Infinity minus infinity is also not a number. Yeah, I think there are some mathematical rules out there which will confirm this behavior. And the other one, which is more the usual null value, like we do it in the relational database in SQL. So when we use a null value, usually it's because we don't know the value. It's an unknown thing, and that was NA say, not available. We don't have a value for that. We can check via functions. If 4 is not available, which is not, NA is not available, of course. And we can also compare things with each other, so infinity equals infinity, as you can see here, to denote the assignment, but to do a comparison, we do the double equal sign. So infinity equals infinity, not a number does not equal a number, but it's not available. Wherever this is not available compared with not a number, it's also not available. Not available compared with not available is not available, and we can also check if it is not infinite, but if something is finite via these functions. There's also metadata available, so if you think about SUS columns, SUS tables, to find out things about the objects we are using. So if I can come up with the variable name A, assign it a vector containing of 1, 2, and 3. We can check this with mode and class that we see. In this case, the mode and the class is numeric, and the str functions shows the structure of the object. So for all the objects, there is the structure function available, and depending on the object, it will show different things. So in this case, it shows us that it's a numeric vector, has a length of 3, so there's 1, 2, 3 elements in it, and the content of the elements is as well 1, 2, 3. We can also define a matrix. So in this case, we see that it's a numeric matrix, and the structure is like 1, 2, 3 rows and just one column with this content. There's a list object out there which is rather complex. With a list you can combine different things. I will not use neither lists nor matrix in my the rest of the demos, but I will concentrate on the data frame, because the data frame is very similar to what tables are in the relational world. Some argue that there is a difference, but I didn't discover one up to now. So I would treat data frames as tables, as I would treat tables in SQL. So when we load stuff into R, we usually use data frames, and that's what we will learn in the rest of the demos, how to cope with data frames, how to work with them. Let's go to data frames. So just to make it simple, I started with 3 vectors. Make a simple, build up a simple data frame. So I have 3 variables which I called COL1, 2, and 3, and then I combine those 3 vectors. You can see here into a data frame. Then display the data frame, and you can see that it looks like a table. We have 3 columns which are called col1, col2, col3. We have 4 lines in it. And we get an index here, which is not part of the data frame, but R, when I show it, the content of the data frame, it automatically shows me the row numbers of the data frame. So that reminds me really about tables. What we can do with the data frame is, for example, we can select one cell in the data frame, which we can't really do in an easy way with SQL. So we can use the name of the data frame, use square brackets, and then select the row number and the column number, like here. So I would expect that it will display the word, the content 32, and it does. Wow, the demo works. We can also select a whole row by only using the first part of the indexing. So if I leave the column part blank in the index, then the whole row and every column will show up. So we get only the column, the row 3 with all of the columns. Or we could also use only the second column by either using the index, like here. So now it's showing the content of the column 2. Unfortunately, it's not showing in columns, but as a line, but that's the content of the column 2, as you can see here, up here. So column 2 is 12 to 42, and it's 12 to 42 here, down here. We can also use the naming. So the dollar is like the dot in SQL. If I use the schema.table name or the table.column name, I can use the dollar sign here. So to display the column 2, I just write df, which is the name of the data frame, dollar, and the name of the column. If you work heavily with just one data frame, then maybe it's a good idea to not always have to write the df and dollar, so you can attach the df data frame and just use the column name. So it will first look up, if you can't find a variable with the name col2, it will look up the data frame df in this case and display the content of this variable, and we can detach this again. Or if it's just for one line of code or for one function call where you use several columns of just the one data frame, we can wrap the thing in the with function, stating that for all those expressions which are part of the second parameter, it always should look up the data frame df to find if there's a variable, a column col2 in it. We can also add things to a data frame, like we can add to tables. So I create a new vector col4, which I combine those values into. And then I can use the cbind function, the column bind function. So I bind a column to an existing data frame. The existing data frame is called df, and the vector I'm binding to is the col4. So now we have a fourth column with all those values from this vector. Then we can also add rows, as you might guess, not with the color bind, but with the row bind function. So in this case, I did not come up with a variable, but adding directly the combine function as a parameter to the row bind function, and I add a fifth row to my data frame, showing up down there. So usually you do not create data frames by creating vectors and then combining them into a data frame, but you already have data out there to analyze. So the usual approach for most of the data scientists is to load stuff via CSV files. So they're downloading stuff from data sources, from web services, or even from your reporting services report or your data warehouse. So they ask you, as the data expert, please give me the data as a CSV file, and then you download the CSV file, load it into memory, into variable in this data frame, and work with that. How can we do this? There's this function setQED for set working directory. So that's a path where my file is is sitting, and then I can just create a data frame. So the readCSV function is returning a data frame, like the thing we already have seen. And through the function readCSV, I state just the file name, which sits in this path there. So we can load the factory seller sales table, as we can see here. Now it's showing up there as the following thing. Let's move up there and zoom in. Online work. So then there's a new data frame, factory seller sales, which is indeed the factory seller sales table from the Essential Works. The data scientists do not talk about rows, but usually they talk about observations or samples. So there are 40 observations out there, 40 rows with 3 variables, so 3 columns in there. And we can see details of that. What's data? It's a list of 3. We get the names. So there's a variable added x. So that's the index. The order date, the sales amount. We see the row names. So there are no. A data frame could really have names for rows. Usually in SQL we do not do that. So I usually do not name my rows in the data frame. It's a data frame, and we can see the data type x is an integer with 40 rows, and this consists of the values 1, 2, and then it's end there. Order date is a factor, so with 40 levels again, because there are 40 different values there, and it's of course a date like here. And then there's the sales amount, again a numeric, 40 values, 1 to 40, with those values there. So factor is an interesting thing if you're into data warehouses. Who is into works with data warehouses? So a factor would be like a lookup table. So usually if you load stuff into a data frame, you can either opt for that the texts are really repeated in every row. That's what you would expect, or like an Excel sheet would look like. And you can also opt for that it's transferred to a factor. So in, every of the possible values gets a number, like in the lookup table, and so it's stored just once. The content is just stored once with an index, and the actual 40 observations are just referring the index to those things. The factors can be ordered or unordered, so depending on the values you're showing, you would opt for example, for the order date, maybe it's a good idea to have an ordered factor, so that the factors are ordered by the values of the date, so that the earlier the date is, the lower the factor number is. So we read several of those files, and as I expected, you already work with a relational database. Maybe you will not opt for exporting your stuff from SQL Server to a CSV file and then loading it again into R, but we could also directly access SQL Server via, for example, ODBC. Yes, there are many packages out there. At least the ODBC thing really works for me. So if you use not only base R, but want to use packages, you have to state this command, install.packages, and then the package name in quotes to install it. So then it's connecting to the ground server, finding the packages, downloading the packages, extracting the package, and installing it on your local machine. So if you want to use this, then you have to install it. If you give the script to another person, then another person is also to install it. Or if you want to run the script on a server, this package is also to be installed on the server. Then you activate the library, so that to state we want to use this library, and in this case the library name is not in quotes. That's a really pitfall. I had some times finding out what's wrong with my code. So for the install packages you have to use the quotes. For the library you don't use the quotes. And then I can come up and create, with the help of this library, I get, for example, this function, ODBC to connect, where I pass in a connection string to my SQL Server, and the connection is then stored in a variable called myConnection. We can either use the ODBC connect, or we could use the ODBC connect. So if you already got an ODBC connection on your machine, then you also have to create it on the servers, of course. Everybody else, you can also use the ODBC connect option to create a connection. And then we can use the SQL query command, passing in the connection just created, and then passing in one SQL statement, which your server can understand. So that's now TSQL or SQL, whatever you want, depending on the connection you're using. So I'm using SQL Server, so I pass in this case it's a very simple query, select star from the product category, or select star from table product subcategory, or I do here as shortcut to select only some stuff, the order date, the sales amount, the sum of the sales amount, and then from the visual sales table, grouping it by order date. So, and then, okay, one message, maybe it was closed again because I was too slow. Yes, I was too slow. So now we also have this fact visual sales filled with the SQL query here, and we can force to close the connection. So we've got data frame, and as I said, data frame is like a table in SQL, so we can work with the data frame almost like with the table in SQL. So if I want to see the content of a table, I usually don't display the whole of the table because then the list is very long, everything is loaded in memory, so I don't use this. But I would rather go for select top of some of the rows. How can we do this in R? We can do this by using the head function. If you use the head function, by default it's showing 6 of the rows of the data frame. And as you can see, there's only one column here, there are other columns up there. So the console, if the console can't display all of the thing in one row, it's just repeating the things. So you get here the first 6 rows for the first columns, order date, English product category name, sales amount, product standard costs. And then we get for the same rows, the other columns just below. That can be a little bit confusing. If you see this here, total product cost, discount amount, English product name, and at the very end the sales amount subcategory are added up and summed up the sales amount. 1 to 6. We can also pass an integer there, so with head 1 we only see one row, and there's also the tail function which shows us the last rows. In this case it's just the last one row. As you can see, there are 441 rows in there in the factory solar sales subcategory data frame, and that matches what we can see here. So the factory solar sales by date subcategory has 441 observations, which is 441 rows. We can select which columns we want to see, projection, by different ways. So one would be to again use the square brackets. So I leave the first index empty, so I get all of the rows. And then I pass in again a vector as the index for my columns. And the vector consists of the names of the columns in again quotes. So I get only the sales amount, the English product category name, and the order date displayed. But in this case, for all the rows, as you can see here. We see. If you work heavy with selections, you might get take a look into the dplyr package. It's a really good package, and it works with piping. So I take the data frame and I pipe it to another function of the dplyr package. So because the creator symbol is already a reserved symbol in the R language, they had to come up with this percentage creator and percentage. But more or less it's just a pipe symbol like you... anybody used to work with Linux? With the pipe symbols there? Yeah, it's a similar thing here in the dplyr package. So I get the data frame and pass it into the pipe, and at the next step in the pipe I got a function select, which I state which columns of the data frame I want to display. In this case, not in quotes, but directly as a text. So that's another way to only see some of the columns. We can also order. So in SQL we would do an order by. In R we're passing in order functions. The first index for the square brackets, which is referring to the rows, I pass in the order function, and the order function returns me all of the indexes of all the rows, ordered by, in this case, the sales amount. So in this case, I get all the rows ordered by sales amount, and as I leave the column index empty, I will get all of the columns for it. So it's not really ordered by this, because that's not the sales amount. I think the sales amount is something up there. It's just too long. Let me see this here, no, not here. So, here we go. What's it here? So that's my order thing, and we get the things ordered by sales amount. As you can see here, the sales amount is ever growing, and the indexing are just shuffled to order these things by the sales amount. We can also use the dplyr, so it's up to you. There are a lot of packages out there. It's up to your taste, what you really like. So you have lots of options, which is on the one hand, as I said, very good because we have lots of options. On the other hand, you have to find out which packages you will work. Maybe agree with your colleagues to agree on some of the packages, so that not every of your scripts has different packages and different syntax, because that's the thing here. The pipe symbol is not a syntax of R, it's a syntax of the dplyr package. So depending on the packages you're using, you have different syntaxes in your scripts, which can confuse people if you're using different packages with different syntaxes. So doing the ordering with the dplyr package would be, again, using the data frame, piping it to the select. So we only select some of the rows, and then I continue with my pipe and give it to the arrange function. I don't know why it's not named order, because arrange does order the stuff, but it's called arrange. So then we get the same list again, but this time only for the 3 rows, which are ordered by the sales amount, as we can see here. How to filter stuff. In SQL, we would use the where clause to state condition that I will only see some of the rows. With R, we already have seen that we can use the square brackets and using indexes here. So again, for the first index, which is referring to the rows, I can state a condition, like factor reseller sales by date subcat English product category name should equal, double equals, the road bikes. So I only get the rows where the subcategory name is road bikes, like here. Or I could combine things, again, doing the in thing, so where column in, and then I state a list of values. It's also available in R. In this case, I use the in could be so that it's stated that it's a keyword and it's not just part of a variable. I already again have to state it with the percentage sign. So subcategory name in, and then I pass in a vector, as we learned in the very first script already. So then I get everything which contains either road bikes or mountain bikes. There's also in the base package a function available called subset, where I already also pass a data frame in with a condition, so that will be end up in the same way, like the first thing, where I use the square brackets. And I also can do this with the dplyr package again, using the data frame, piping in to select, only select some of the rows, ordering it by sales amount, and then piping it into the filter function. So it's not called where, but it's called filter, and I can filter to the road bikes and get the very same list, but filtered by road bikes. To only get distinct values in a data frame, in SQL you would use the distinct keyword. In R it's the unique function. So get only unique rows, then I pass in the data frame to the unique function, and it should only show me unique values. All of the values are already unique, so I again get 141 rows here. Doing aggregation is easy in SQL. You use the group by to group things and aggregate. In the projection you're using aggregate functions like min, max, sum, count, and so on. We can use a similar approach in R. I opted for the dplyr package for this example. So again, we take a data frame. I create a new data frame to make it easier to see what's happening here. So I'm creating a data frame. The first column will be named A, capital A, and consists of the value 1, 1, 2, 3, 3. And the second column is called B in this data frame and consists of the values 2, 3, 3, 5, 6. So when I create this and show the data frame, we have a data frame with 5 rows and the value 1, 1, 2, 3, 3, 2, 3, 3, 5, 6 in the B column. If we then group by A, that would be the first column, and summarize B, I would expect that I don't see just value 1 appearing once in A, and then we'll sum up the B's. It will be 2 plus 3 is 5. There's only one value for 2, so this will stay at 3, and for 3 we will get 5 plus 6 should be 11 if I calculate it right, and that's what we get here. So for 1, it's grouped by the column A, and the column B ID is summarized and added up. Don't get confused by this here. The dplyr package adds here the data type. So the rows, the numeric values are doubles in this case. So dbl is double. We can use the very same with our factory result sales data. So we pipe it again and group it by English product category name. Summarize the sales amount as sum. So there's a new column in the output of the data frame which is called sales amount sum, and it's calculated as a sum of the sales amount column. And that's what we get here. So we get accessories, bikes, clothing, components with their sum of sales in the data frame. Again, we see the double here, and FCTR means factor, so that's factorized column. We can also calculate totals and percentages. So again, taking the data frame, grouping by the English product category name, and summarize up at the one hand the sales amount sum, and also the sales amount total, which is the sum of the sales amount, factory result sales amount. So we get the total here, and we can calculate the percentage by dividing the sum of sales amount by the sum of the data frame dollar sales amount multiplied by 100, so that should end up in the percentage we are using, or how the sales is spread about. So we see here again the sales amount per category, the total sales amount, so the sum of all 4 of the rows, and then we have calculated the percentages. And if you know the differential works, you know that bikes are the goods which are sales most in this database. We can also add calculated columns. So that would be the mutate function in the dplyr package. So I add a new column, margin, which is just subtracting the total product cost from the sales amount, and then display this in my output. So we get the total, the margin calculated here, like we will see if I scroll up there. Again. So the margin is added to the data frame. We can also join 2 data frames with each other. So I come up again with the artificial data frame here. So data frame 1, which has one column, the customer ID, which is 1, 1, 2, 3, 3 again, with different sales amounts. And then I come up with data frame 2, which again has customer IDs 1, 2, 3, so 1 to 4, so 3 is missing here, with the names X, Y, and Z, very creative, I guess. And then we can do different joins. So we can do an auto join, and the join is called merge. Like, is anybody into integration services? Yeah. There's also this merge join, which is the join, and there's a merge, which is not a merge join. In this case, we merge, we join via the function called to merge. So we pass in one data frame, the second data frame, we pass in the column by which it should be merged, and I pass in that I want to see all of the rows from each of the data frames, so that's what an outer join will be. So we get all the rows from both data frames. So we get the values 20, 30, 30, and so on. There is no sales amount for customer with ID 4, so we get this not available here. And there is no name for customer 3, so we get this not available here. And basically that's it, because with the all, we can now, with the all parameter, we can now decide if you want to see all of the one data frame, all of the other data frames. So the left outer join would be that we want to see only all of the X thing, and the X thing is the first parameter, the first data frame. So we get all the rows from the first data frame with all the sales amount, with missing values here, because we don't have any names in the second data frame. Or we can decide to use all of the rows of the second data frame, and then see that for the customer 4 there is no sales amount in the first data frame. We can also use cross joins. Ever need a cross join? Who ever need the cross join in production? Okay? In production? Yeah? Okay? Okay? Should be very rare, yeah? But it's out there. Yeah. Cool. How are we doing time-wise? 10 minutes left? Really? Wow, I'm chatty today. So I have to really speed up now, because I want to show you really cool stuff. And that's, I said, you use R for as language, for statistics. The second thing is for machine learning. So why would you use R in your SQL Server database when you already have SQL knowledge? So why should you get used to this? Because we can do predictions. It's a really nice thing, and I have to speed up because that's a cool thing I really want to show you. So there is this package Prophet. Yeah, that's a cool name because it's really looking into the future. It's a quite new thing. I think it was published at the beginning of March. This developed by people from Facebook. So they are doing projections into the future. It's a really cool package. So what I'm doing here, I take my factory sales, only use the order date and the sales amount, and assign it to another data frame, my profit data frame. Then I rename the columns there because the profit package expects that the date has the name DS, and the value we want to project into the future has to be called Y. Don't ask me why. Then I make sure that this DS is actually a date. So I convert it there, and then I get rid of the dates. Because for the factory sales, I only have some values for different days within 1 month. So I can't do projections for every day, that would be silly, but I can only do projections for the whole of the month. So I overwrite every day with the beginning of the month, and then I use the dplyr package to aggregate by this date and sum up the summaries. So we get one sales amount per month, and the date for the month is the beginning of the month. That's something the profit package can work with. Then I create a model by calling the profit function and passing in my data frame. Then I create a new data frame which is looking into the future. So I want it based on my profit model, and I want to look 6 months, 6 periods into the future, and this is month because the frequency is monthly. Then I do the forecast. So I do the prediction using my data model, and the prediction will be passed into this using the future period, and the result will be in the my profit forecast. Then I merge into the forecast, I merge in the previous data frame, so I get the old rows, the past, merged with the future thing, so we can query on it. And as you can see, if I take a look at this last 7 rows there, we get very interesting columns there. Let's take a look at the columns. So we get DS is the date, the order date. Then there's this T, which is the trend. So the package really analyzes is there a trend in the data over the years, like linear regression. Then it also analyzes how the seasonal thing is throughout the month. So according to the trend, maybe some of the months would not be right at the trend, but above or below that. And it also can cope with trends within the weeks. So for example, maybe your customers will buy stuff from Monday to Saturday, but your shop is not open on Sunday, then it will be empty, and this package will cope with that and show the right things. And to get really interesting, I use the ggplot package, and then we can plot the thing. So that's the third thing. I said statistics, descriptive statistics, prediction, machine learning, and visualization. That's what R is really good at. So we can use the ggplot without explaining, because I'm really running out of time. Having 5 minutes to finish my talk. And what we can see here is that we can now project, that's the past, and the profit package calculated that we will continue like this. And it's really good, so fantastically using this package, and it's astounding how precise the thing is. So we are calculating the predictions for every day, and then compare it, what was the prediction 2 weeks ago for today, and then we see what was today, and it's really, really close. So it's a really good package. You should check it out if you want to have something look into the future. So, 5 minutes to go. What do I shortcut now? What's really good is that some of the stuff is really good integrated into the data platform. So, if we take Power BI, that we have in Power BI we have 3 places where R is already integrated. So if you are used to R, You can use this in Power BI. One place is, like here the visualization, that's a visualization I did not make with Power BI things, but it's an R script. So when we take a look here, you should recognize that, yeah, I get the data from the Power BI model. The data is automatically named automatically passed in a data frame which is called dataset. So I just copy pasted my package, my script I just showed you, where I came up with the visualization. I just entered this here to copy the content of the dataset, which is the name of the dataset I get from Power BI, to the fact visualizations, and then I just can use my script as it was to build up this visualization. We can also use R as a second place when we get data, so we can use an R script as a data source, like I did here. Again, this is the code you already have seen in my R script. So maybe it's a silly thing now, because Power BI is really good at connecting to a relational database, so I would never use this in production, but it's just to show you that I can just copy and paste my script I just used in the Visual Studio, paste it in here, and now I can connect data from the data model, from the relational database into the data model of R. And I already also used it for doing transformations. So that's the third thing we can do in Power BI. We can use an R script to convert or transform the data you have in the model before it gets into the model. So, 2 minutes to go, so I'm going back to slides. Just summed up, the integration to reporting services is really simple because there is no integration to reporting services. The only thing we can use is that you use, I didn't show this. Coming back to here, just take 1 second. So what we can do is that we can also run R scripts in SQL Server. So there's this procedure called SP external script, and we pass in that the language will be in R, and then I pass in a script, which is a very simple one. I just take the input set and assigning it to the output set. I just pass it through to make it really simple. And for the input set, I can state a query. So I don't have to use the RODBC connection to connect R to the SQL Server, but just pass in stuff from SQL Server as a parameter to the thing. And that's what I do when I want to visualize things in SQL Server. Reporting services, I write a wrapper procedure which is calling the SP execute external script, and use this when I create the dataset in reporting services. Integration services is always also the same. So there is no integration. We can call, for example, the SP external script command via execute SQL task, for example, to use R. With Power BI it's really great because we can use R scripts as a data source, as a transformation, and as a visual. And in Azure Machine Learning, I did not have time for this, there's 2 elements there, the execute R script and the create R model. So machine learning, Azure Machine Learning is not known for having many of these machine learning algorithms out there, but you can use R to create your own model, parameterize your own model, and use this out there in Azure. So that's I come to the end. So why should you think about integrating R to the SQL Server using R? Usually the data scientists take the data, move it to R, execute the script local in memory, and the new way would be to move the script where the data already is. So take the script and execute it on the SQL Server where the data already resides. Also resource governance or security could be a topic, because if people get stuff in CSV files, we don't have any, so they can forward this CSV file to anybody. We don't, yeah, security is just a mess in this case, and we can operationalize our model. So we can create procedures, models out there, and every application, every user who can work with SQL Server can utilize the R scripts out there. I've shown you some of the pitfalls. So, okay, sensitivity, state and state looks very the same for people working with SQL Server. This will not work, only this works. Or we can use the dot as a part of the parameter, and sometimes we have to use the quotes, and sometimes we are not allowed to use the quotes, but there could be pitfalls. Yeah. Conclusion, R is really easy to learn. There are use cases out there, so you will not use R for every of the use cases, but there are some of the use cases where you should consider using R, and R is really greatly integrated into the Microsoft data platform. With that said, thanks to the sponsors. If you have any questions, just come to me. Thank you very much.